Okay guys, so today we're going to finish Science Chapter 11, Lesson 4. So you should have your science books out and you should have your vocabulary notebook out. You should be open to the Chapter 11, Lesson 4 vocabulary that we did the other day, because any words that come up in this next section, we are going to add to that list. Go ahead and open up your science books to page 518 and listen while I read out, or follow along while I read out loud. What are inclined planes? Suppose you are moving a heavy desk onto a truck. Would you lift the desk to get it on the truck? That would take a lot of effort, and probably a helper or two. A better plan would be to push the desk up a ramp. That way you don't actually have to lift it, you're just pushing it along the ground. A ramp is an inclined plane. An inclined plane is a simple machine with one part, a flat, slanted surface. This machine holds up or supports most of the load's weight. So, word number 7, I think we're on number 7. If we aren't on number 7, then just you write it correctly in your notebook. Number 7 is the word inclined plane. And an inclined plane is a simple machine with one part. So it's a simple machine with only one part that holds up most of an object's weight. That way you are not the one having to do it. If you and a friend decide to lift that desk up onto the back of the truck, you are doing all the work. Whereas if you use a ramp or an inclined plane, you can push it up, which means you're doing less work because the ramp or the inclined plane is what's holding the weight of the desk. You're just pushing that weight up the ramp. Inclined planes make it easier for people with physical disabilities to get around. You find inclined planes at the corners of sidewalks, and they are often at the entrances to buildings. That's because, well, first of all, some of them may be in a wheelchair, which you cannot go up or down steps on a wheelchair. You have to roll up or roll down. Another reason is that it's easier, again, because they don't have to do as much effort to lift themselves up a step. They just have to walk up like normal. It's just going up a little ramp. With an inclined plane, you only need a small effort force. However, you have to move the load farther. Look at the photo. The cable must pull the car up the entire length of the ramp. The ramp is longer than the distance needed to lift the car straight up. So what that means if I have, say this is the back of a truck and I'm lifting a desk. I would lift the desk, I'm going to move this further. I would lift the desk from right here to put it on the back of the truck. So I'm not moving it quite so far, but I'm still having to use a lot of effort to lift that heavy desk and put it up here. Whereas if I have a ramp, the ramp might come down, so pretend there's a ramp coming down, and I am going to put the desk on the ramp, and then I'm going to push it up onto the back of the truck. Now, yes, I did have to move a lot further than if I just lifted it right from the back of the truck, but again, it's worth it because I'm using a lot less effort. Sometimes the long way is the easier way. That's just how it is. So if we look at this picture of the car going up this ramp, we can see that ramp probably on like a tow truck, and it's pulling it up. Now, if people wanted to lift the car, they'd only have to lift it from here to here, but again, that would take so many people and so much work. Let's see. Okay, let's move on. We'll wait to talk about the screw after we read this next part. Okay, so let's look at page 519. Now we're talking about wedges and screws. What do you get if you put two inclined planes back to back? You get a simple machine called a wedge. A wedge changes, a wedge changes a downward or forward force into a sideways force. So, let's look at the picture at the bottom. We're looking at this diagram on page 519, and let's look at the bottom at the picture of the peach. We see, or a mango. I don't know what that, maybe a mango. I don't see a pit, so it must be a mango. We see that that knife has cut the mango into two pieces. A knife is an example of a wedge because a ramp, oh, here it is, looks like this. That is a ramp. Now a wedge is like two ramps placed back to back. Now, on a knife, you may not be able to see this, but if you look really, really closely, here's the point of the knife, like the sharpest part, and if you look really, really closely, please don't do this unless your parents help you. You can see that on either side of that really, really sharp point of the knife, you can see where it's almost molded just a little bit to where it looks like a wedge coming up. So what that wedge does is it's changing that force. You're putting the force on the handle of the knife. And what it is doing, it is then putting that force on this object. We'll say that's the mango. So it's changing the force from here to here. Now another type, a screw, is an inclined plane twisted into a spiral. To see how, you can cut a piece of paper into a right triangle. A right triangle looks like just one side of a wedge, like this. That is what a right triangle looks like, because it has a right angle right there. Wrap the triangle around a pencil. Watch how the slanted edge of the triangle goes up and around the pencil. So a screw, we can see at the top of page 518, we can see a picture of a screw, and what happens is, as you're turning that screw, that inclined plane that's wrapped around the screw helps to cut through the wood or whatever you're putting that screw into so that you don't have to push so hard because you're twisting it and twisting it. And that little, oh, what's the word I'm trying to look for? Spiral around it kind of cuts through and helps it to go down without as much effort from you having to push it through a piece of wood, like if you were using a nail and a hammer. The hammer and nail requires a lot more effort than using a screw. We can also see a screw, another example of a screw, in that middle picture on page 519. We see a drill. A drill has a screw at the end of it. Like all inclined planes, wedges and screws trade, like all inclined planes, wedges and screws trade distance for effort force. So that means they move from a further distance, so they have longer to move, or they have further to move the object, but they don't require as much effort. Often, we use them on a very small scale. We use knives to cut food. We use drills to make holes in wood and metal. So let's look at this photo again on page 519, this diagram, and pay close attention because you might see it again, hint, hint. We have a ramp, so we have a man pushing a heavy box up a ramp. Now that does look like it's requiring a lot of work, but imagine how much more work it would require if he didn't have that ramp and he just had to lift it onto the back of that truck. And then we have a screw, which is where we see a drill drilling into a piece of wood or metal. I'm not sure what that is. Imagine, so it does have to do work, but imagine how much more work it would take if we had to take our hands and just push it into that metal. It probably wouldn't happen. We would not have enough effort to push that nail, if we used a nail instead of a screw, into that metal. And then with the mango, we have that knife, that wedge, cutting like we talked about here. So what I want you to do, we kind of already talked about it, but what I want you to do is look at this photo and pick one of those simple machines and decide how it makes the task easier. Now that's up to you, because I've already kind of explained it, so I want you to come up with your own words on how one of these simple machines is making the task easier. So you can pause this video and do that now. And now when you come back, we're going to do the quick check on the bottom of page 519. So remember, that means I ask the question, you pause the video, write the answer in your notebook, and then you play it and check your answer. So compare and contrast. How are a knife and a screw similar? How are they different? Well, both a screw and a knife are types of inclined planes. A knife applies force in a straight line, but a screw applies force in a circular motion. Because remember, as you're screwing that in, it's twisting. That spiral is letting it twist inside that wood or that metal or whatever you're trying to drill a hole in. Now, the critical thinking question. Which would be easier? Walking up a gradual ramp, that means like it just slowly goes up, or a steep ramp, which means it goes up really quickly. Like this would be, I keep losing my marker. This would be a steep ramp. This would be a gradual ramp. So which one requires more effort? The gradual ramp or the steep ramp? And then explain. Well, the gradual ramp. You can just imagine this in real life. It would be a lot easier to walk up this ramp than this one. So the inclined plane helps to do the work by decreasing the force or making it less effort over a longer distance. So that means that a steep ramp has a shorter length, which means it doesn't lower the effort as much as this longer ramp. A longer ramp would be a more gradual ramp, which means the effort would be less and less, because the whole point of a ramp or an inclined plane is to make the effort less over a longer distance. So if you made a shorter distance, well, the effort isn't going to be as, it's going to be more than on a more gradual ramp. Okay, go ahead and turn the page, and let's read this last page together. How do simple machines work together? Two or more simple machines form a compound machine. So let's add that to our vocabulary. Number 8 is a compound machine. And a compound machine is two or more simple machines working together. We know the difference between simple and compound because of grammar. So we know simple is a simple sentence is one clause, and a compound sentence is two or more clauses put together in the same sentence. So that will help you to remember. Simple machine is one, a machine that has very little parts, whereas a compound machine is two or more of those simple machines working together. Most machines are compound machines. Scissors, for example, are made of two wedges. The wedges act as first-class levers. When you push the handles together, the blades cut. So if we look at these scissors right here, we can see that the wedges are the metal parts that actually do the cutting. Because we know if we cut with scissors, if we are using scissors, we're cutting that paper. So what it basically is it's two wedges or two knives that work on a lever where you're pushing on, let's draw some scissors really quick. Oh my gosh, why? So here are the wedges. Here's the fulcrum, and here's where you apply the force, the effort force. So, when you push on these sides, they push these two wedges, that fulcrum helps to push these two wedges together so that it will cut that piece of paper. That's my drawing of a piece of paper. It's hard to draw a 2D piece of paper on the board, especially sideways. So as we put effort over here, that fulcrum makes these two wedges come together to cut that piece of paper. Bicycles combine all kinds of simple machines. The handlebars, pedals, and brake controls are levers. So remember, you put your, on the handlebars, you squeeze those brakes, which are levers that then make the brakes work. The gears and chain are part of the axle that moves the wheel. Screws of different sizes hold the parts in place. Efficiency. A machine can save you time and energy, yet no machine can change all the energy of an effort force into work. So no matter how much effort you put on it, it's not, a simple machine will never put all of that effort into whatever it is doing. Only some of the energy that comes out of a machine is useful. Efficiency means how much work a machine produces compared to the amount of work applied. Friction reduces the efficiency of any machine. We already know that friction is, it works against any force. So friction seems like the enemy. However, it's not, because without friction, think of that marble rolling across the floor. It would go forever. It would never, ever stop. So we need friction. But friction can also cause problems because it means that our machines that we use or whatever work we're doing, we're not always getting every single bit of work out compared to the force that we put in. So now let's look at the quick check on page 520. Same thing. I'll ask the question, you pause the video, answer it in your notebook, play the video, and check. Compare and contrast. How is a compound machine different from a simple machine? So this time you only, even though it says compare and contrast, you only have to say what's different. Well, a compound machine is made up of two or more simple machines. So a simple machine has only a few moving parts, or only has a few parts, whereas a compound machine is several of those simple machines put together, so therefore it has a lot more parts. Now the critical thinking question. How are a knife and a pair of scissors related? Well, they're both made up of levers and wedges. A scissors is made up of two wedges and two levers. So either side is a lever. Whereas a knife contains one wedge and one lever. So let's see, I'll show you what that looks like with a knife. So here's, it's a terrible picture of a knife, but oh well. Ugh, I can't do it. Whatever. Okay. It's a butcher knife. Whatever. And here's our object. So this is also a lever. Here's the wedge. The fulcrum is here. Even though you can't actually see the fulcrum like you can in scissors or like pliers or something, it's over here. We push down. The effort force goes down here. And then this pushes down on the object. So, that is how they are related. They also both cut things. Okay, very good. So, that's the end of chapter 11, lesson 4. It is also the end of chapter 11. You will have a test next Wednesday. So we won't have a science video on Monday because I expect you to use that time to study and then reach out to me if you have any questions. Even though it is open book, open note, in order to do really well on the science test, you kind of already have to have a good idea of what's going on and just maybe have to flip back to certain pieces to get a little more, to certain parts of the chapter to get a little more detail. Okay, so you do have independent practice and then homework. So go ahead and get out your Friday packet and open up past the Phantom Tollbooth quiz And then here is your guided practice. It's a diagram sheet, so you can find this diagram on page 519. Remember, some of the questions can be answered just by looking at the pictures. Some you need to look at the what it says in the book around the pictures, and some are critical thinking, which means you take what you see in the picture and what you read in the book and what you already know, and you put it together to create a new answer. Make sure to write in complete sentences. You do have space. And make sure to fully answer questions. Then, after you're finished with that, there is no back to it, and you have homework. You have the Simple Machines, or the Chapter 11 Lesson 4 outline. You did the vocabulary the other day. Now you have the outline. Make sure that for the critical thinking question, you fully answer the question. They give you a lot of space because you should need quite a bit of space. Okay, so go ahead and get started on the guided practice, and then you can do the homework now, or you can wait and do it later today. If you have any questions about this lesson, go ahead and reach out to me between 1 and 5.